So you got this down to your notes now about amplitude and period. These are both things that we actually were already using as we were working through yesterday's work. It's just that we didn't necessarily name them and talk about them explicitly. So taking a look at these ideas, so amplitude, that's the vertical distance from the midline, so notice a little bit of embedded vocabulary there as well, to the top or bottom of a periodic function. Now when we say a periodic function, that's just a function that repeats some pattern as we go along, and hence our cosine graph is periodic because it's just this wave function that just keeps continuing over and over and over again. So the vertical distance from the midline to the top or bottom of a periodic. If I'm looking at the parent function, cosine of x, what's the amplitude of that equation? Yeah, the midline for our parent function is 1. Because if I'm graphing this, I would have my midline and then I'd be going one above it and one below it. Now, it is a common confusion to think, well, maybe it's 2 because the total height is 2. But notice it's not the total height, it's the distance from the midline to the top or the bottom. So that's why it starts out as 1. And of course, we will be able to change it as well. And then period. We also use the idea of period, although in that case it was more just kind of a default thing. Because the period is how long it takes to basically complete one full cycle. That means how long it takes to start repeating itself. How many degrees does it take for cosine to start repeating all of the exact same values? It's 360, because when I go through there, I have gone through all of my cosine values from, actually in cosine it's looking like this, we've gone from 0 up to 360 with that. And then after that, remember, it just starts repeating itself, right? It's the exact same thing, because of course you're getting right back to the same place on the circle. And so the default is 360 degrees for our cosine period. Now I say default for both of these because we are going to be changing them as we go forward, and that's going to be part of what we're looking at today. Particularly looking at how we change period, because we've already seen how we change amplitude. Remember, we multiplied cosine by something. And actually, let's get specific on that. Let's say I want to make my amplitude 2. I would write y equals 2 cosine of x. Notice the 2 is in front of cosine. What happens, though, if we put the 2 inside with x? That's going to be something new. That is a transformation we have not done this year. As it turns out, it changes the period. So, add this to your notes, and we're going to then see how to actually use and apply it. So, you'll notice here, b is this value which changes the period. Now, generally speaking, I don't want to memorize 2 different names and uses for b. And so I tend not to actually use the proper vocabulary for b. But if you are so interested, b actually has its own little name. b is called the frequency. Why do I not worry about using that and having you have to know it? Because I've found that as soon as I expect you to know frequency and period, all of a sudden we can't keep straight which one's which. So I'm going to focus just on you knowing the critical thing is that b changes the period, and it determines what our period is. And it does so with this, because b determines the number of cycles within a normal circle. So like normally it's 360, right? All of them that we have seen so far have been like cosine just of theta, or x. Remember, it doesn't matter if I call it theta or x, it means the same thing. So in all of these cases so far, my b value has been 1. Notice 360 divided by 1 gives me 360. And so we can go ahead and get that same thing. You'll also notice one other little detail in here. You notice radians is coming up now. In the near future, we will be doing this graphing in radians as well as degrees. And of course, you know how the radians work because they're just a different way of measuring an angle, right? You've practiced that a lot over the last few weeks. It's going to be the same thing when we get there as well. But we start with degrees just because I find them a little bit easier to wrap our head around and get all the big ideas down. All right, now for today, our main focus is going to be on this one right here. We're going to be working in degrees. And when in degrees, to calculate our period, we're going to be doing 360 divided by our B value. Because that B changes how many times we complete a cycle within 3C. To get specific, I want to start with two very specific examples because they help us to see this. And yes, you probably want to write these down, although it's not necessarily required. So you notice for this first one, we know y equals cosine of 2 theta. So B is 2 there. That means that I am completing 2 cycles, where I used to just complete 1. That is between 0 and 360. And so, whereas I used to just complete 1 cycle, I'm now going to be completing 2. Therefore, you'll notice that the whole thing has been squished. Hence, our new period is 180 because a single cycle is completed in half the space. All right, and then the second one, you can see if I put a 1/2 inside, there my B value is 1/2. So that means that between my normal 0 and 360, I'm only completing half of my cosine. The other half would be after that. And so if the other half is after that, it's taking twice as long to do it. Hence, my period then is 720. And you can see the calculations there. Go ahead and add all that stuff down to your notes. And you want to keep this information handy here. Today we're just going to be looking at how we do these calculations. So today we're going to be just focused on this process. But tomorrow we're then going to be using this information to actually make graphs where we've changed the period. Because of that, these two examples are actually going to be the ones that come up most tomorrow. So you definitely want to have this handy just because it helps us to remember what these are doing. And one little other side note before we go and start just practicing the calculation pieces here. If we're going to describe this as a transformation, so like our shifts in our stretches and our reflections, how would we describe what B is doing to this graph? So when I have that number inside, we're multiplying. When we've seen multiplying before, it's always been a stretch. So like if I put the 2 out front of cosine, that's a vertical stretch. Still, multiplying is going to be a type of stretch. But this, for the first time in this class that we have seen, it's actually a horizontal stretch or compression. Because you can see, like if I take my normal cosine graph and I put the 2 inside, what that's going to do is it's going to mean that I'm instead going to be doing my cosine graph squished in. And so it ends up being a horizontal stretch or compression. And interestingly enough, and this is something we will delve into a little bit more later, I think, you'll notice that when I multiply by 2, it actually compresses it. When we multiply by a half, it actually stretches it. This is actually kind of like our shift left and right. Remember when we shift left and right, minus goes right and plus goes left? It's kind of backwards from what you would expect. The same thing happens with the horizontal stretches. Multiplying by 2 actually shrinks it in, and multiplying by a half actually stretches it out. So some interesting little details that come along the way there. All right, so in order to do these, notice there's actually 3 questions for each of these. For each of these equations, we don't have to graph it, but we do need to figure out what would the period be, what would the amplitude be, and what would the midline be. Because once we can nail down this part of the process of identifying what they are, then we can go on to graphing them, because then it'll be a lot easier. All right, so for each one, period, amplitude, midline. First step, let's figure out the period, our new piece today. How do we calculate period when we are in degrees? Yeah, we're going to be doing 360 divided by whatever that B value is. So for this first one, to find my period, I'm going to do 360 divided by 2. This is reminiscent of our notes, right? And so 360 divided by 2 gives me 180, so the period is 180 degrees. In other words, if I were making this graph, I'd be completing a full cycle from top down to bottom and back to the top between 0 and 180. That, remember, is what period really means here. Right, next up, amplitude. Amplitude comes from our vertical stretch. So amplitude is changed by whatever number is multiplied out front of cosine. But in this case, there's nothing multiplied out front of cosine. So what would the amplitude be? Well, if it's unchanged, yeah, it's a 1. Because I could write a 1 in here and it still equals the same thing, right? 1 times cosine is the same as the cosine. All right, and the midline. The midline always comes from our vertical shift. So in other words, how far has it been moved up or down? So in this case, how far has this one been moved up or down? Yeah, it's the -5 here. So it's been moved down 5. But I don't want to just write -5 for my midline, because it's a line. And -5 isn't a line, it's a number. If I want to make it a line, I write it as an equation then. So I'd actually write it as y equals -5. That way it's actually the equation of the horizontal line through -5. And that's the same kind of pattern you're going to be doing on the others. So having seen this first example, go ahead and do the other 3 on your own, and then we'll check them through here together. All right, and so these are the answers you should have found for each of those. So you can go ahead and compare them to what you came up with. A couple things to note here: when there was no number multiplied out front of our thetas, notice the period didn't change. So those, your period is just 360. The number that's multiplied out front, remember that is your amplitude. And if there's no number added on to the end, notice my midline is 0. Because if we don't change it, it starts out as being 0 there. Just like when we don't write the amplitude in and out front, it's assumed to be 1. Yeah, now this one up here, notice our amplitude is 4. I remember what amplitude our definition is. Our definition of amplitude is the distance from the midline to the top or the bottom of my wave. It's a distance. Since it's a distance, it must always be a positive value. So the actual 4 gives us our amplitude. The negative, that's just flipping it upside down, but it doesn't change how far up or down we go. And I guess one other thing to note here, you notice the number that's inside that we add or subtract? It's that horizontal shift, so where we're moving it left or right. Notice that does not affect the period, amplitude, or midline. It's just the horizontal shift.